Trigonometry, Chapter 6, Inverse Circular Trig Functions and Trig Equations, Section 1, Inverse Circular Functions, Video 2.1, A Quick Comment About Notation. If you're wondering why it's Video 2.1, it's because I had already created the PowerPoints for all the other videos and realized I meant to put something about notation, and this is a good place to insert it. Now, using the traditional algebraic notation for an inverse function, we can write the inverse of any trig function using the -1 notation, such as the inverse of sine of x is sine inverse of x. The inverse of cosine of x is cosine inverse of x. The little -1 is read as inverse, and we can do it for all 6 trig functions, 5 of which we'll get to soon. We've already analyzed sine. However, there is a second notation for inverse trig functions called the arc trig functions. Watch the 6 inverse trig functions on the right side of the sentences as I switch to the next slide. See what happened? They all lost their -1s and picked up the word arc in front of them. Arc sine, arc cosine, arc tangent, arc cosecant, arc secant, arc cotangent. Now, why would we do this? Well, this is often used when the algebraic notation with the little -1 is combined with exponential expressions, because after all, things that live up here normally represent exponents. So when you have things living up there that represent 2 different things at the same time, it can get confusing. But what does arc sine even mean, or where does that come from? Well, you might imagine that it comes from an arc of a circle, and you would be right. If you view trig through the perspective of a unit circle, the definitions are defined by the coordinates of the terminal point of an arc. For example, here's theta in a circle of radius r. I know it's not a unit circle until we say it's 1. The point on the circle is x comma y, and here's the arc length s. Now, recall that if theta is in standard position, then the length of the arc S is given by S equals R theta, as long as theta is measured in radians. Now, for a unit circle, since R equals 1, this equation collapses down to S equals theta. Thus, we can define trig functions in terms of the arc S, such as sine of S is equal to Y. Remember, we're assuming this is a unit circle now, so instead of y over r, it would just be y. In terms of an inverse trig function, instead of saying sine of s equals y, we could say s equals arc sine of y. So s is the arc whose sine equals y. Did you hear it? S is the arc whose sine equals y. The phrase "the arc whose sine equals" is reduced to just arc sine. And that's where the phrase arc sine come from. Arc sine of y is the arc whose sine is y. So as we move forward, any instance of the phrase arc cosine or arc tangent just means the inverse trig function. And I'll admit, since I'm writing this after all the other videos were made, I did not use the arc notation in the other videos, but I have seen it in homework problems go back and forth between the arc notation and the -1 notation. So just understand that they both mean the same thing. And I believe that's the end of this video, and it is.